This is Pangea. It's a supercontinent we've all learned about in school. It formed around 300 million years ago when most of Earth's landmasses joined together and broke apart again around 175 million years ago to form the continents we have today. But while it's widely accepted that Pangea existed, scientists have been arguing for a long time about whether or not the supercontinent was actually one giant landmass or instead a collection of smaller ones that were fused together like puzzle pieces. And recent research suggests that the answer might lie much further back in Earth's history. Welcome to my channel. It's me, and this is Crash Course Geography. The idea of Pangea was proposed by German scientists Alfred Wegener in 1912. He was trying to explain how fossils of the same ancient organisms ended up on completely separate land masses like Africa and South America. To Wegener, it seemed more likely that those lands had once been connected and split apart than that the animals had somehow migrated between them across vast stretches of ocean. Today, scientists accept that Wegener's original Pangean supercontinent existed but disagree over its exact size and shape, because they couldn't agree on what the edges of the continent looked like. Some think that Pangea was surrounded by one global ocean called Pangea. Others believe that there were multiple smaller seas that jutted out from it. And since Pangea formed so long ago, it's really hard to tell. There isn't any direct evidence left on the Earth's surface of how it broke apart, because the geologic record only goes back about 65 million years. Beyond that, the rocks have either been destroyed or recycled through plate tectonics, which means we don't have any way of telling how many other smaller landmasses there were or if they were all fused together like puzzle pieces. But there may be evidence of something like that recorded in rocks billions of years old. Most models for how Pangea formed assume that it was mostly made up of older cratons. These are the stable portions of continental crust that have been around for billions of years. Take the North American craton, for example, also called Laurentia. It began forming around 3.8 billion years ago and today makes up the stable portion of Canada, the western United States, and part of the easternmost seafloor of the Atlantic Ocean. If you took Pangea and put its pieces back together the way Wegener imagined it, Laurentia would make up the southeastern corner of the supercontinent. And it turns out that the process of putting Laurentia together was very similar to how Pangea came to be. Around 1 billion years ago, the pieces of what would eventually become the North American continent were scattered across the globe. Then they began colliding and fusing until they joined together and created Rodinia. That's a name that comes from the Greek word for protected ones, which refers to these ancient cratons being protected from destruction deep within the Earth's mantle. Rodinia was Earth's first supercontinent. Well, maybe not the very first, because we have found evidence of every single supercontinent that's ever formed. But it was the first one that scientists have pretty much agreed on. It began assembling around 1.1 billion years ago and reached its fully formed state somewhere around 750 million years ago. At this point, most of the major rock types that make up continental crust had already formed. So the process of creating Rodinia didn't involve a whole lot of new rock formation. Instead, it was mostly made of older pieces that were shuffled around. In fact, many scientists believe that Rodinia wasn't even one coherent landmass, but instead a collection of cratons surrounded by mobile belts, which are thinner slices of rock that formed along the boundaries between cratons. So in a way, Rodinia was kind of like Pangea. Scientists know it existed, but they can't agree on how many pieces there were or exactly how they fit together. And just like with Pangea, we can't see the physical evidence of how Rodinia broke apart. That's why understanding how it formed is so important. The oldest part of Rodinia was the African craton, also called Congo. Like Laurentia, Congo began forming more than 3.5 billion years ago, and today it makes up most of West and Central Africa, as well as a small part of the eastern Atlantic seafloor. But early in Earth's history, Congo was an island arc, a curved chain of mountains that forms when two tectonic plates collide and one is forced under the other. Island arcs are still forming today, like the Mariana Islands, Japan and New Zealand. But back then, they were much larger, and they combined with other island arcs and pieces of continental crust to create the foundation of Rodinia. One of the biggest island arcs that got incorporated was called the Barberton Greenstone Belt. Today, it's found in South Africa, but 1 billion years ago it was near the equator and part of a much larger landmass. As more island arcs and pieces of continental crust collided with each other, mountain ranges rose up along the edges of the growing landmass. For example, the Makadisho Mobile Belt formed when the Congo Craton collided with the Tanzania Craton. Those collisions pushed the rocks deep into the Earth's mantle, where they were heated and folded until they hardened back into metamorphic rock. And that process of pushing rocks deep into the mantle and creating mountains is still happening today along the convergent plate boundary between the Pacific and Philippine plates. It's just slower and happens over millions of years. Eventually, the entire eastern portion of Rodinia was ringed by mountain ranges. They were some of the earliest mountain chains on Earth, and they played an important role in how life evolved. The process of building mountains exposes rocks deep within the Earth's mantle that weren't there before. They include minerals like granite, which are full of nutrients like phosphorus and potassium that are essential for life. As the rocks weather and erode, those nutrients are released into the surrounding environment, soil and water, creating conditions ripe for the evolution of complex life. In fact, researchers believe that the evolution of multicellular organisms during the late Precambrian and early Cambrian periods happened in this exact region. In a study published in 2022, researchers used computer modeling to recreate the formation of Rodinia. They wanted to find out how quickly the nutrient-rich rock from the newly exposed mantle would weather and become part of the ecosystem. Their results suggested that Rodinia's mountain building created the perfect condition for large, complex organisms to evolve, which led to the explosion of life we see in the fossil record during the Cambrian explosion. So while we may never know exactly what the continents of Rodinia looked like, or how many individual cratons and mobile belts made it up, we do know that its formation played a huge role in how life evolved on Earth. After Rodinia formed, the Earth's surface remained relatively stable for hundreds of millions of years. But around 750 million years ago, the supercontinent began to break apart. It started with rifting, where magma pushed up from the mantle and split the land apart. Eventually, seawater flooded the cracks and the supercontinent broke into smaller, scattered landmasses. And that process of breaking apart happened again and again throughout Earth's history, eventually leading to the formation of Pangea. So the next time you're putting together a jigsaw puzzle, remember that it's a lot like how scientists believe Earth's continents move and change over time. And just like a puzzle, the deeper we look into plate tectonics, the more we learn. Like in 2023, scientists announced that they discovered a new type of plate boundary that helps explain how Antarctica's transantarctic mountains formed. Stay tuned to learn more. Thanks for watching this episode, which was filmed at a studio and was made with the help of all these nice people. If you want to help keep this content free for everyone forever, you can join our community on a crowdfunding platform.